Hi, I'm Bernard Parsons from Bcrypt, and I'm going to talk today about product certification for full disk encryption products. So these are products that encrypt the entire hard drive of a laptop or a desktop so that you can be confident that if they're lost or stolen, no one's going to get access, no unauthorized individuals are going to get access to that, to the information on the laptops. So we argue that product certification is one of the key factors that you should be thinking about in the process of selecting FDE products. It's not the only important thing, so usability is very important, for example, ease of deployment, ease of use, but usability is something that you can test very easily as an organization. Just get hold of a free trial and set the thing up and see how easy it is to deploy and manage. How well the product has been designed and implemented from a security perspective, so how much security is it actually buying you, is much more difficult to assess yourself as a buyer, and that's the real value of third-party certification, where independent experts have really looked under the hood of a product and tested how good the security really is. Why should you care? Well, really, it's about reducing the risk that 3 months after you deploying the product, you're going to read in the media about some vulnerability that's been discovered and exposed in the product that you're using that then you're going to have to react to, and that could be costly, refresh, replacement, etc. So it's about trying to reduce the risk to the organization and make sure that if you're going through the effort of deploying encryption, you're deploying something of quality. So you don't really need to know all of this detail, but what I'm attempting to do here is just give a flavor of some of the things that certification processes look at within encryption products, but also I'm really trying to highlight the differences between different certification processes. So within the UK, the two most popular are FIPS, which is the Federal Information Processing Standard. It's actually a US set of standards run by NIST, and the National Institute of Standards and Technology within the US. And there's the CPA process, Commercial Product Assurance Scheme, that's run by the National Cybersecurity Centre here within the UK. And they are complementary. CPA, as I'm going to show, is much more comprehensive, but it does make use of FIPS and is complementary with FIPS. So the kind of things that the experts that run these schemes are going to care about when they're looking under the hood at a product: keys, algorithms, architecture and implementation. And this pretty much goes across the board for many different types of security products. So, but if it's an encryption product, the strength of the product is very dependent upon the strength of the keys and how the keys are managed. So keys are just data, strings of ones and zeros, but those ones and zeros have to be highly random in order to make the product resistant to an attack. And both of these schemes are going to require that vendors can prove that they've got the appropriate processes and algorithms in place to generate strong keys. So no difference there. But beyond the generation of a key, you need to care about whether there's anything in the product that unnecessarily exposes that key or inappropriately shares that key. So is it, for example, easy for another application running on the same device as the encryption product without any special elevated privileges? Is it easy for that application, for example, to gain access to that key? So a piece of malware gaining access in a trivial way to that encryption key so that the product can then be circumvented. Is the key appropriately shared amongst a large community of users within an organization? Is it duplicated in an inappropriate way, meaning that an exposure somewhere or a loss by one device somewhere could have implications to the entire user community? So it's only the CPA process that undertakes an assessment comprehensive enough to look at those kind of characteristics. Moving on to algorithms, so all products use standard algorithms these days called advanced encryption standard, AES, is one example. SHA is another type of algorithm. A standard hashing algorithm is an example. So there's not much to talk about in terms of difference of algorithms across products. It comes more down to how well the algorithms have been implemented, or rather, have they been implemented correctly. And again, both schemes obviously are going to require that vendors can prove that that is the case. So that's pretty straightforward. As we move on to architecture, really what we're talking about here are things at the product architectural level that may undermine the encryption that's been implemented correctly. So for example, can users on devices without any special administrative privileges change the policy of the product? So this is a problem with some commercial products. A normal user could just decide, I want to decrypt this device. I don't want encryption on my device for whatever reason they invent. So there's no way for an organization to be confident that even though they deployed encryption, actually their entire state remain encrypted and they remain compliant with the data regulations that apply to them. So having appropriate controls in who can change policy, who can decrypt an encrypted device, ensuring that it's straightforward for password recovery or even key recovery tools to be executed by authorized individuals, and ensuring that those tools introduce no vulnerabilities into the product. So again, it's really the CPA scheme that you need to have an assessment undertaken of those characteristics of the product. And then lastly, implementation. So if we do a very good job of the encryption and the architecture of the product, but then a poor job of actually implementing it, then everything is undermined. We could be inadvertently introducing vulnerabilities into the software itself that can be exploited. So there needs to be an assessment of the coding quality of the organization, build standards, processes around handling products, validating the integrity of the products and delivery, etc. And again, it's the CPA scheme that will provide an assessment of those characteristics. So there's quite a significant difference between those two schemes. One is very focused on encryption, the other requires that as a starting point, but is very focused on the overall architecture and product implementation. So buying a product that you know has been through that level of comprehensive evaluation by an independent third party means that as an organization you've done as much as you can to reduce the risk that there are inappropriate vulnerabilities in the encryption product that you're buying. Thank you.